Good morning, afternoon, and evening to everyone joining. Welcome to you all. Fraud is on the increase, and really, if we look at the systems that help identify fraudulent activity, then they need to start to become more and more sophisticated to deal with this rise in fraud. What they need to be able to do is to spot this fraudulent transaction quickly, but also accurately as well. As you've gather, machine learning and artificial intelligence are currently one of the hottest topics in technology today. And I really feel that they can be used to help with the battle against fraud. So over the next 25 minutes, I will talk to you about how companies, in conjunction with H2O technology, can increase the number of fraudulent activities that can be identified, but without compromising on the speed at which this is performed. Feel free to ask any questions as we go along today, either in the question and answer window within Zoom or the chat panel that you have. I will try and pick up on these, but please do remember that I have a big difficulty in multitasking, as I'm constantly reminded by my wife and daughters. So, my name is John Spooner, and let me just quickly introduce you to me in the form of numbers. How else would someone else do this who has a degree in applied statistics and has been working in the AI industry for 23 years? I've worked with many organizations on their AI strategy over the last few decades, whether it's been large financial organizations who want to automate their fraud decisioning, a major telecommunication company who wanted to speed up getting their hundreds of cross-sell models into production, or whether it was the major UK retailer who wanted to use millions of models to underpin their product recommendation strategy. So I would say it's well over 100 customers that I've worked with over my career. And currently, I have the pleasure of being employed by the #1 open software company in the world, specializing in artificial intelligence and machine learning, and that company being H2O. What we're trying to do is to democratize AI, and through automation, what we're doing is allowing our customers to build hundreds, thousands, and millions of machine learning models that make data scientists and data analysts so much more efficient and valuable to their organization. So, as I said right at the start, fraud is a massive issue. In fact, it is the most commonly experienced crime in the UK. Currently, it costs the UK economy many billions of pounds every single year. And criminals are becoming more and more cunning in their attempts to steal our money, vendors' money, government's money, and there's no sign of this changing. If we look at the latest statistics from the Office of National Statistics, there are an estimated 4.6 million incidents of fraud in 2020 alone. And this has grown, as we can see, over the last 2 years, regardless of it being consumer, retail, bank, or credit account fraud. So what is really driving this upturn? Well, clearly the increased use of online services by customers and business for many different aspects of day-to-day life is really driving this. And this was only accelerated by the COVID-19 pandemic. It really is starting to lead criminals to focus their efforts on defrauding people through any sort of online fraud and scam. And if we think about it, the fraudsters are getting more and more sophisticated in the methods that they use. And we need to make sure that we are utilizing the latest advancements in technology and data to stay one step ahead of the criminal. If I was to look at the current status with the current fraud identification systems that are being used by organizations, then I would say there's probably 5 main issues. The first one is that a lot of these systems are only considering a handful of features or inputs about either a person or process to work out whether something is good or it's bad. And fraudsters are getting more sophisticated in their activity. And the simplistic summarizations that potentially are being used in our fraud identification systems really won't allow us to pick up the most advanced fraud schemes or scams. Secondly, the features that are being used that have been identified are being put together into rule-based systems. And these rule-based systems are typically built up by humans. So if this happens, or this happens, or this happens, or this happens, then this transaction may be fraud. And many fraud systems are made up of thousands of rules. And that combination of rules can deliver an acceptable level of accuracy. The problem with it is that the management of these systems can become really unwieldy over time. Customers' normal behavior and criminal fraud behavior is constantly changing. So trying to isolate new and different fraud patterns can be really difficult to spot if these systems are not updated regularly. Trying to update rule-based systems manually can be incredibly time-consuming and labor-intensive, and therefore costly. Third, there are always improvements to be made with regards to the accuracy of these systems. Many organizations that I've spoken to suffer from identifying what is called too many false positives. The incorrect identification of an activity to be fraudulent when in fact it wasn't. And the impact of this can be twofold. Either it can affect customer satisfaction in, say, a financial payment use case if the customer felt that their card is being stopped too often, or alternatively, a business can be incurring a large investigation cost as they have to increase the number of manual checks that have to be made when suspicious activity is flagged by these systems. Trust is the fourth important aspect of any fraud identification system. The advantage of the rule-based systems that we talked about earlier that are currently in place really makes it easy to see how these systems are making their decisions. Reason codes are easily created, so decisions can be explained to customers, internal stakeholders, and regulators about how the systems are thinking, and this builds an element of trust in the decision-making. Any improvement that we make in these systems needs to make sure that any trust is maintained. In certain situations, such as transaction monitoring, you only have a millisecond or a sub-millisecond to make the right decision. The speed at which this decision is made is critical. And historically, rules-based decisioning systems allowed us to make very quick decisions. But as we increase the sophistication of those systems, then if we wait too long to make the most accurate decision, then the opportunity to identify the fraud has gone and it is too late. That fraud has taken place and any loss or negative impact has already incurred. And as we said right at the start, the fraudsters are constantly changing their behavior. So this whole system needs to be constantly updated. More and more digital activity is happening at a greater velocity, and fraudsters need to be put into place. So how do we get to a point where we're updating these systems quickly with as little human interaction as possible? And we really need to strike the right balance, and that can be difficult. So, if we think about if we put too many features into our fraud decision making process, our accuracy goes up, but the speed at which it takes to make the decision goes down. Move from a traditional rules-based approach to maybe something more complicated, and that complexity people don't understand fully, then that can affect the trust in the systems. Decreasing the number of false positives that have to be manually checked by a domain expert can put jobs at risk. However, applying certain principles in the area of artificial intelligence to this massive business challenge can really help strike a balance across all of these. So where does artificial intelligence, or its abbreviation AI, come into play? Well, the first one is identifying the key features that can explain the behavior of an individual, a process, or transaction. If we think about and read numerous amounts of research, then it's been proved that the more data that you have, both from a breadth perspective, i.e. information that you have about a transaction, and a depth perspective, i.e. the more information you have about the behavior that you are trying to identify, then the more accurate you're going to be in fully understanding the overall behavior. And think of this as the computing equivalent of really gaining human experience. So this suggests that when possible, you can really improve the accuracy of your current fraud system by just expanding the number of features that you consider. However, this is where current methodologies do break down. Trying to find which bits of information really affect working out your behavior can take a long time to identify. And machine learning can help accelerate this. Machine learning refers to the analytical techniques that learn those patterns in the data sets without being guided by a human analyst. And the machine learning models can really pick up those behaviors incredibly quickly, and is a really good first step in helping organizations improve their ability to identify fraud. The next evolution of improving our fraud identification systems is to use machine learning algorithms to build a machine learning model that automatically identifies fraud. So using features about previous transactions that were both fraudulent and non-fraudulent, this technique would generate logic that will be able to predict which future transactions will be fraudulent. These machine learning models can either completely replace or augment the rules-based systems by efficiently determining which transactions are most likely to be fraudulent. And it has been found that these models significantly reduce the number of false positives that traditional systems generate. A number of organizations have ripped out their rule-based systems to replace them with machine learning models, but many organizations have put a sidecar associated to their rules-based decisioning engines. So they put their transactions through the rule-based system and they're enhanced by the machine learning models. And that's a happy medium. As organized crime activity, as we've said, is really sophisticated and can change quickly, defense strategies based on any single one-size-fits-all won't necessarily produce an optimal result. And we need to make sure that we're quickly building these supervised models. Organizations that have embarked on this journey has found that the process of building these machine learning models can be time consuming. So data scientists can spend a number of weeks or months going from that historical customer and transactional data, creating new features of that data, finding the best machine learning model, and then deploying that model, that whole process can take a huge amount of time. And as we've said, we haven't got time, as fraudsters are constantly changing this process. So to help accelerate this, a whole new discipline has emerged in machine learning called AutoML. And this helps automate a lot of the manual process that data scientists go through to build these models. And H2O is at the leading edge of this particular discipline through a component of its product portfolio. In terms of what H2O does, is we are a software organization, and we have software called the H2O Hybrid Cloud that really helps organizations identify fraud quickly. And we do this based on three major principles: make, operate, and innovate. So our hybrid cloud allows organizations to quickly make the machine learning models and build machine learning models with a huge degree of accuracy, speed, and transparency. But we can also turn those models into applications that business users can utilize. And we have the capability to allow data scientists to build those applications with the same amount of accuracy, speed, and transparency that we do with our machine learning models. Machine learning models are complete and utter waste of time if we can't utilize those. So as part of the H2O hybrid cloud, we're able to quickly operate those machine learning models in applications with agility and confidence to allow the organization to make better decisions faster. And then we're able to start to innovate on, or help data scientists innovate with new data sources, with new types of ways of analyzing the data and new types of ways of displaying that data and decisions to an end user. To help to demonstrate these particular concepts, then I am going to use a fraud data table. Unfortunately, there's a lack of public available data sets in the domain of fraud detection. However, this data table that is summarized on this particular slide does help highlight the key benefits of machine learning to solve this particular business challenge. So we can see here that in this data table, we have transactions that have been reported as fraudulent, and we've got information about those transactions. So the type of transaction, the amount, the different places of origination, the balances of origination, and where the transaction is going to. So let me move into H2O hybrid cloud. So what you're seeing here is a number of different applications that have been created. And we can see here, as part of the hybrid cloud, we've got a number of different applications that have been built for different types of fraud analysis. We've got fraud across healthcare. We've got fraud, we've got check fraud, so the ability to read in images. And then we've got a general fraud analysis application. And this particular application enables us to have a high-level dashboard that explains what's currently going on with the current fraud system. But behind this is a machine learning model that is predicting which transactions that are coming through the system are likely to be fraud. So as part of this hybrid cloud, we have an AI engine, and the AI engine allows us to build the most accurate model possible in the fastest amount of time, given the data that we have. So if we go into that model building tool This model building tool is referred to as driverless AI, and driverless AI allows us to quickly build these machine learning models at every click of a button. And what you're seeing here is driverless AI currently building a machine learning model, going through a number of different iterations. In the top right-hand corner, we can see the settings that the user specified when they wanted to build this experiment. An experiment is the methodology that we go through to build a machine learning model. So we've got a pretty high level of accuracy. We want it to run pretty quickly, and we're interested in a mid-level of interpretability. We just click go, and then what driverless AI does is sift through all of the data that we have. So in this particular case, all 6 million transactions, of which some of them have been identified as fraud, some of them identified as not fraud, and then using the 11 columns to try and pick out which are the key features that identify fraud. But as we can see here in the middle, what is happening is driverless AI is not just using the original columns that we have within the data, but it's manipulating that data fully to try and squeeze out the patterns within that fraudulent target variable to see, can we make this machine learning model more accurate? And it's this automation that really accelerates the data science productivity, but also increases the amount of, increases the speed at which this process then takes. So that's how a machine learning model will get built using hybrid cloud. But once that model has been built, then what we need to make sure we do is maintain trust. And the big challenge that we have is the machine learning algorithms, whether it be methodologies such as gradient boosting or decision trees or neural networks, is the more complicated they get, i.e. improve the level of accuracy that they predict at, then the more complicated that they get, and therefore the ability to explain those results become very hard. So what you're seeing on this particular screen is, on the right-hand side, a technical architecture of a neural network, and trying to understand the inner workings of that becomes really, really hard. Very, very different to that on the left-hand side, that is a very simple rules-based system. So how do we get to that point of balancing something that's highly sophisticated but maintaining trust? But fortunately, a lot of research has also been done in this particular area as well. And I would really recommend that you check out a lot of the work that H2O has done around the whole area of responsible AI. The topic itself is very, very vast, and we could probably do a webinar on that particular topic in itself. But all I'm going to say in this particular session is, at a high level, what we need to know is, how is that complicated machine learning model making its decisions? And overall, this is something that we call global interpretation. This is about knowing what are the key characteristics or features that are important in differentiating between fraud and non-fraud. It is critical that we make sure that protected characteristics such as gender, race, sexual orientation, or even proxy features that maybe mimic these types of characteristics are not being used in the machine learning model. We don't want these machine learning models to give unfair or discriminatory treatment to certain individuals. And it is also important to know what are the specific details about an individual transaction that has caused it to be flagged as fraud. This individual interpretation is known as a local interpretation. So we have global, that is about overall, what are the features that are driving the prediction? And then local is what is it about this particular transaction that makes it identified as fraudulent or non-fraudulent. And the hybrid cloud from H2O can generate interpretability for all of the machine learning models that have been created. And then finally, once the machine learning models have been built, they do have to be put into production. And that itself is a whole discipline. And a whole discipline has built up that is referred to as model ops, or sometimes called ML ops. And that's where it's made up of three key components. Something called production model deployment, that is all about getting models up and running on production infrastructure where they can be served. This is really, really important for fraud detection systems, because you need to make sure that those predictions are delivered at a very, very low latency and a high throughput. The second area is model lifecycle management. And this is where you need to automate as many of the processes as possible to make sure that your model is performing as expected. So think of it as a way of keeping those models that you have healthy, troubleshooting any production issues that you have, and then automating the process of updating those models when needed. And because of the constant change in fraudulent behavior and customer activity, then it is really, really important that we have that in place. And then there's a whole area around production model governance. And this is a whole area that will give you controls that you need to ensure that your models are safe and you have all the information that is needed for a legal and regulatory issue. And within hybrid cloud, we can then see we have a whole area called My Models. And within My Models, we have different projects that relate to the ML ops of that particular machine learning model that is in production. So where have we seen our customers gain value from this? We look at, first of all, AT&T. This is a really, really great use case because they've seen an 80% reduction in fraud by moving from rules-based decisioning only to using artificial intelligence and machine learning models. And as you can see, it wasn't a instant reduction. They started to use rules only and modifying those rules and saw some improvement in accuracy. Then they started to build a handful of machine learning models. And we can see in that purple line that a big decrease in the number of fraud events that were identified. And then by using artificial machine learning, again, a lower number of fraud events actually existed. So another organization that is using H2O technology is PayPal. And the reason that I brought this up is they had a very, very good system before we spoke to them. But they were able to increase their level of accuracy from 89%, which they thought was really good, to something even better of 95%. And they did that by speeding up their processes, building more models, and automating a lot of that process. But what was also key was, as part of a hybrid cloud, you also get automatic generation of documentation of the full model building and validation process. So not only did they have a highly accurate model, but they also had it fully documented for regulatory purposes. So really, to summarize, machine learning, as we've seen, can be applied, and it's not just theoretical. We've got use cases and customers doing that. Machine learning can be applied to improve fraud identification, both quickly and accurately. We can see that we can reduce the time that it takes to identify key features because we're removing that manual process of identifying lots of data. Machine learning algorithms can increase the accuracy by finding out the real subtle patterns within the data that'd be very hard for a human to spot manually. We're able to start to automate all parts of that process, that identification of features, building the machine learning models, driving that accuracy up, but without compromising the speed of deployment, speed of execution of those models in production, and also maintaining trust in the systems by utilizing interpretability as well. All of the software that I've demonstrated very quickly within this particular webinar is available for you to use on a 14-day free trial. So feel free to go to this particular link to get some hands-on experience of that technology. So, just having a look at the question and answer session. So, regarding the automated tuning of features, analyzing the data patterns, how can that be reproducible? It'd be important to have log information about the concrete procedures and transformations. So that's a really good question, Angel. What happens as part of that automated machine learning process? We get insight into what were the features that were analyzed and what were the features that were created. And those will automatically appear in the automated documentation. So as that automated documentation gives you your log information. Okay, any more questions from anyone?
I did get a few questions, John. Thank you.
Yeah, go for it.
So how do you avoid bias like gender, race?
So really, really good question. And the key thing with that is through the machine learning interpretability metrics that come out of hybrid cloud. So what you're able to do is to look at those and start to assess through a number of different charts, is age, gender, or is the model discriminating across age or gender or any of those predicted characteristics? And it's not just looking at the model itself to say, well, are those protected characteristics in the model? Because actually the model may have created new features that act as a proxy of those. So it's about going into that machine learning interpretability and testing for those protected characteristics. I can also see another question that's coming on the chat. Do we have an API, or does H2O have an API for Python or R? The answer is yes. It has an API for both Python and for R. So you're able to be in a notebook of your choice and make a call out to the software components as part of the hybrid cloud.
Thanks, John. Do organizations need to share production data with H2O, or can the solution run on their own cloud accounts?
So H2O software runs both on an organization's cloud environment, whether that be, and that can run on any cloud, Google, Microsoft, or AWS. But this software can also run on internal systems as well. So you've got a really hybrid approach of where you install the H2O hybrid cloud.
Great, thanks, John. Another question came in. Can fraud be detected if the data is not classified as fraud or not fraud?
So it becomes harder because at the end of the day, the supervised machine learning models need a target or a label to try and predict and differentiate between fraud and not fraud. However, if you don't have labeled data, there are unsupervised machine learning techniques that you can use to start to identify groups of transactions that are different from each other. So while it may not give you an exact, this transaction is fraud, this transaction is not fraud, it gives you more of a clue of where to go looking at unusual transactions. And unusual transactions may mean that that transaction is fraudulent, but it also may mean there's just an anomaly within that particular person's profile. Fraud can be like searching for a needle in a haystack, but machine learning techniques can help you really pinpoint where you should be looking and what you should be looking for. And that's where unsupervised learning techniques really come to their own.
Great, thanks, John. Another question, what are available options to bring data into the H2O platform?
So there's a number of different options. H2O have a number of different data connectors, whether those be connectors that can bring in SAP data or AWS data, or simple CSV type files. We have a wealth of ways of importing data into the system.
Great. Is there any anonymization functions to secure the sensitive data?
So that's really, really good question. At the current time point, we have made the assumption that the data has already been anonymized before it then gets brought into the H2O software.
Great, thanks. And how reliable, flexible, and customizable is the platform?
So reliable, it's incredibly reliable, both from a uptime perspective, but also in terms of how accurate the models are that come out of the system. Flexible, incredibly flexible, so lots of data can be brought in. The applications that you're seeing on the screen at the moment can be built from a very custom perspective because of the framework that can be used by data scientists. With regards to AutoML, the data scientist does have full flexibility of how that machine learning model gets built. And then we've got flexibility with regards to the deployment of those models. They can go into any particular framework. And then there was a third one, wasn't there, Ivan, that I can't remember?
It was reliability, flexibility, and customization.
And so customization, a huge amount of customization based on how a product, how an application looks, but also how you could then bring in specific custom recipes to build your own specific machine learning model based on maybe some company IP that you've built up in machine learning over the years. I also see another question of, does H2O support data imported from Parquet? Yes, it does. It's able to import Parquet files into the system.
Great. Well, thank you, John. I don't see any other question. Thank you for taking the time today, and thank you to everyone who joined us. We would love to get your feedback on this webinar and the next topics you would like us to cover. So please answer the quick survey that will show up after we close the event. We hope you enjoyed the presentation. Stay tuned for upcoming events and have a great day.
Excellent. Thank you, everyone. Take care.
Thank you. Bye.